Check out our familiar home, this swirling blue and green marble we call Earth. When we think of a normal planet, this is the blueprint. It's got a rocky crust, plenty of water, and a nice, breathable atmosphere wrapped around it. It's a classic. But if you could peel back all that water and soil, you'd realize that everything we see on the surface is really just the packaging for something much denser hidden deep inside. Exactly. Think of Earth like a giant cosmic jawbreaker. You've got this massive, thick outer layer made of rock and magma, and then right in the center, there's a smaller, heavy metal core. That metal center is mostly iron and nickel, but it only makes up about a third of Earth's total mass. Most of what makes Earth Earth is that rocky shell. So here is the big what if. Imagine you could reach out and strip away every single bit of that rock. You'd be left with just that central metal sphere, a naked ball of iron flying through the vacuum of space. That sounds like something out of a sci-fi movie. A planet that's basically just a solid hunk of metal? It feels like we're missing the rest of the ingredients. Standard models for how planets are born show that dust, gas, and rock usually clump together in fairly predictable ratios. When a star system is forming, you'd expect a planet to grab plenty of rocks to go along with its metal. Right, finding a world that somehow ignored all the available rock and just kept the metal is a huge outlier in our data. It suggests that something happened to interrupt the normal clumping process. But we don't have to imagine it, because we have a real-world example right in our own backyard. Mercury. Look at that. It looks a lot like our moon, all cratered and gray, but Mercury is incredibly deceptive. It has a tiny, thin crust of rock, but the vast majority of its inside is one giant, oversized iron core. It's the heavy metal world of our solar system. Seeing a world like Mercury up close forces us to rethink the way solar systems are built. If a planet can end up as a naked metal core, it means the birth of a star system is way more chaotic than the textbooks usually say. It's like finding a car that's all engine and no bodywork. We have to figure out where the rest of the parts went. To understand these iron worlds, we have to talk about density. Iron is much heavier for its size than rock is. Think of it like a bowling ball versus a beach ball. They might be the same size, but that bowling ball is packed with way more stuff. Iron planets are the bowling balls of the universe, small but incredibly heavy. That density creates a wild gravity anomaly. Because gravity comes from mass, a tiny planet made of solid iron can pull on you just as hard as a rocky planet 3 or 4 times its size. So if you are standing on a small iron world, you'd feel just as heavy as you do right here on Earth.
It's like a giant magnet for gravity. This brings us to the mechanical mystery. How do you actually get a naked iron core? What forces are powerful enough to peel away a planet's rocky skin and leave its heart exposed? The first possibility is the hit and run. Imagine a young, normal planet, crust and all, getting involved in a total smash-up with another planet-sized object. It's a high-speed cosmic fender bender, but on a scale that would wipe out everything.
In that collision, the lighter rocky layers on the outside get completely shattered and blasted away into deep space. But that iron core, it's so dense and tough that it survives the crash. The rock turns into dust and drifting debris, leaving only the indestructible iron heart behind to continue its orbit. But there's another way to peel a planet, and it's a bit slower. We call this theory the solar blowtorch. This happens when a planet forms or migrates way too close to its host star. We're talking danger zone close. At that range, the heat is so intense that the rock on the surface literally begins to boil. Over billions of years, the star's radiation and solar winds vaporize the rocky crust and blow it away like steam from a kettle. The iron core has a much higher melting point, so it stays solid while the rest of the planet just evaporates into space. These iron worlds aren't born as metal balls. They are the scarred survivors of extreme cosmic violence, either smashed or scorched until only their metal bones are left. So if we could actually build a ship tough enough to get there, what would it physically feel like to step out onto the surface of one of these things? You'd be dealing with the most extreme temperature swings you can imagine. Metal is a great conductor of heat. The side facing the sun would be a scorching furnace,
but the dark side would be a freezing vacuum, colder than any place on Earth. And remember, there's no rocky crust or atmosphere to act as a blanket. You're standing on raw metal, totally exposed to the unfiltered radiation of space. It's like standing on a hot stove in a freezer. Plus, that massive exposed metallic core creates wild magnetic fields. You'd probably see incredible auroras, but your electronic equipment would be going haywire from all that magnetic energy. Standing on one of these worlds is equivalent to walking through an exposed planetary engine room, a high-voltage, unshielded environment that is among the most hostile in the galaxy. Definitely not a vacation spot. That brings us to the big question everyone asks about space. Could anything actually live there? Maybe some kind of metal-eating alien? As much as we'd love to find iron aliens, it's just not happening. With those temperature swings and the total lack of water or air, life as we understand it is impossible. It's just too chemically unstable for cells to form. So if they're dead worlds, why are scientists so obsessed with finding them? Is Mercury just a weird one-off in our little corner of space? To find out, astronomers are using tools like the Hubble Space Telescope to look far beyond our solar system. They're hunting for supermercuries, giant versions of our metal neighbor orbiting distant stars, and they're finding them. We're discovering massive planets out there that are way too dense to be made of rock. Finding them proves that those violent planetary collisions and solar blowtorches are happening all over the galaxy. These heavy metal worlds are the evidence of a cosmic demolition derby. By mapping out where these survivors are, we're finally learning how chaotic and messy the birth of a solar system really is. It turns out the universe isn't just a quiet place. It's a high-energy workshop where planets are forged in fire and ice.